After empirical formula and molecular formula, another important term that we have to learn is percentage of composition. Percentage of composition. Percentage of composition means weight of one element of a compound that present in 100 grams of that compound is said to be percentage of composition. Simple example I give you. Calcium carbonate. Calcium carbonate. Calcium atomic weight is 40. Carbon atomic weight is 12. Oxygen atomic weight is 16. 3 oxygen atoms are there. Total 48. So if you add this, you will get 100. So 100 is the molecular weight of calcium carbonate. So in 100 grams of calcium carbonate, we will have 40 grams of calcium, 12 grams of carbon, 48 grams of oxygen. So these are the percentages itself. That means calcium carbonate contains 40% of calcium, 12% of carbon and 48% oxygen. That we call it as percentage of composition. Since calcium carbonate molecular weight is 100, it is easy for us to get it. But if all compounds molecular weight is not 100, in such cases we have to calculate the percentages separately. For example, if you take NaOH, NaOH contains sodium, oxygen and hydrogen. Sodium atomic weight is 23. Oxygen atomic weight is 16. Hydrogen atomic weight is 1. So the sum will become 40. That means 40 grams of sodium hydroxide contain 23 grams of sodium. Now percentage means how much sodium that was present in 100 grams of sodium carbonate. So 40 grams of NaOH contain 23 grams of sodium. Now the percentage of sodium is, for that means that sodium that present in 100 grams of NaOH. So 100 grams of NaOH contains how many grams? 100 by 40 into 23. That means 56%. 56%. That is percentage composition of sodium. So here sodium, this is 100, this is molecular weight and this is weight of substance, that element. So similarly for oxygen, percentage of oxygen is weight of oxygen 16 by molecular weight 40 into 100, that is 40%. So sodium hydroxide contain 56% of sodium, 40% of oxygen. The rest is hydrogen. Hydrogen, percentage of hydrogen. So weight of hydrogen is 1 by 40 into 100. That is 2.5. Sorry, this is not 56, it is exact value is 57 point, because 4, 5 4s are 20, 30, 6 4, 7 4s are 7 fours are 28, 7 5. So it is 57.5. So percentage of sodium is 57.5, percentage of oxygen is 40, and percentage of hydrogen is 2.5. If you add all these three, you will get 100. So the percentage compositions of each element in a compound, the sum of all the elements percentage of compositions will be equal to 100. This is percentage of composition. Percentage of composition means weight of an element of a compound that present in 100 grams of that compound. Weight of an element of a compound, weight of an element of a compound that present in 100 grams of that compound. 100 grams of that compound is known as percentage of that element in that compound. By this way, we can calculate percentage of composition of different compounds. So if we know the percentage of compositions, we can easily get empirical formula, and if we know the molecular weight, we can get the molecular formula of the compound. An organic compound is found to contain 40% of carbon, 6.67% of hydrogen, 53.33% oxygen. If its molecular weight is 180, what is its molecular formula? So here, in this problem, we have an organic compound. The organic compound contains carbon, hydrogen and oxygen. So elements, percentage of composition. Atomic ratio. Simple ratio. Empirical formula. So here, this is the procedure. Elements are carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen. Percentage of carbon is 40%. Percentage of hydrogen is 6.67%. Percentage of oxygen is 53.33%. Now, how to get this atomic ratio? We get the atomic ratio by dividing the percentage of composition by its atomic weights. Carbon atomic weight is 12, so 40 by 12. Hydrogen atomic weight is 1, so 6.67 by 1. Oxygen's atomic weight is 16, so 53.33 by 16. So if we divide their percentage of compositions with atomic weights, (3.33), 6.67, this is also 3.33. By dividing the percentage of composition with their atomic weights, respect to atomic weights, carbon percentage of composition by carbon atomic weight, hydrogen percentage of composition by hydrogen atomic weight, oxygen percentage of composition by oxygen's atomic weight, we'll get atomic ratio. Then next column is simple ratio. How to get the simple ratio? From these atomic ratios, all the atomic ratios should be divided by its least one value. Least value is 3.33. That means 3.33 by 3.33, 6.67 by 3.33, 3.33 by 3.33. This is 1, this is 2, this is 1. So the simple ratio is 1:2:1. Carbon 1, hydrogen 2, oxygen 1. So empirical formula is CHO. 1:2:1. So empirical formula is CH2O. This is the way to get empirical formula. From this empirical formula, we can get the empirical formula weight. Empirical formula, carbon atomic weight is 12. Hydrogen is 1. 2 hydrogens are there. 2 into 1, 2. Plus oxygen is 16. So this sum will be equal to 30. Empirical formula weight is 30. Now, molecular weight is 180. Molecular weight is 180. Molecular weight. (180). Empirical formula weight. (30). So molecular weight by empirical formula weight is N. So N is equal to molecular weight by empirical formula weight. So empirical molecular weight is 180, empirical formula weight is 30, so N is equal to 6. That means this is the number with which we have to multiply the simple ratio to get the molecular formula. That is the exact ratio. So simple ratio is 1:2:1. If you multiply this with 6, you will get 6:12:6. So molecular formula is C6H12O6. So that is the way to get molecular formula from empirical formula. So these problems are very simple. So in examination, board examinations, particularly in IPE, AP and Telangana regions, from this chapter, 4 marks questions, either from oxidation, balancing of equation, or from this. In addition to that, in 2 marks questions also, problem will be given from this. Suppose sometimes they will give us empirical formula and ask us directly empirical formula. Instead of doing all this thing, they will give, suppose for example, empirical formula of a compound is CH2O. Its molecular weight is 90. What is its molecular formula? CH2O. Empirical formula weight is 30. Molecular weight is 90. 90 by 30, 3. So N value is 3. So molecular formula will be C3H6O. Like that they may ask for as a 2 marks questions also you can get from this. So here in this topic we have three terms: molecular formula, empirical formula, percentage of composition. Just now I explained you how to calculate the percentage of compositions. So if already percentage of compositions are calculated, we can easily get empirical formula from that data. If we know the molecular weight and empirical formula, we can easily get the molecular formula.
This of a compound found to contain 10.06% of carbon, 0.84% of hydrogen, 89.1% of chlorine. Calculate its empirical formula. So similarly, just like a previous problem, we have to write down a tabular form. First column is elements, second column is percentage of composition, third column is atomic ratio, and fourth column is simple ratio. Now the elements are carbon, hydrogen and chlorine. Percentage of compositions: carbon is 10.06%, hydrogen is 0.84%, chlorine is 89.1%. Now atomic ratio, we'll get atomic ratio simply by dividing percentage of composition with atomic number. Carbon percentage of composition is 10.06, simply by dividing percentage of composition of carbon by 12. Similarly, percentage of composition of hydrogen is 0.84 by 1. Chlorine 89.1 by 35.5. So here by dividing this you will get 0.84. This is also 0.84 and this is 2.51. So by dividing the percentage of compositions with atomic weights of the respective elements, we will get an atomic ratio. From this we have to get simple ratio. We will get the simple ratio by dividing the all atomic weight ratios by least one. That means here three numbers: 0.84, 0.84, 2.51. The least one is 0.84. So for to get simple ratio, all atomic ratio 0.84 by 0.84, 0.84 by 0.84, 2.51 by 0.84. So that we will get 1, 1 and 1. Sorry, 3. So that the simple ratio is carbon 1, hydrogen 1 and chlorine 3. So empirical formula: carbon, hydrogen, chlorine. 1, 1, 3. So empirical formula is CHCl3. 1, 1, 3. CHCl3. CHCl3. This is chloroform.